Let's walk through how Mosaic AI and agent evaluation help you build high-quality agents. Today, we're going to focus on the third and fourth steps of the agent lifecycle: labeling evaluation data and iteratively identifying and fixing root causes of quality issues. Now, some of the customer challenges we've heard here are, first, how do I get an evaluation data set that's diverse and representative without my SMEs spending months labeling? Two, once I have that data set, what are the right metrics to evaluate quality? How do I trust the output of those metrics? Three, once I have metrics, how do I quickly pinpoint exactly the root cause of any quality problems I see so I can fix them? Four, once I've identified a root cause, I need to evaluate many different ideas to try and fix it. How do I first quickly run evaluation so that the majority of my time isn't spent waiting? Two, how do I track those different versions of my agent so when one works, I can know exactly what code and config I need to deploy? And then, if my fix isn't working, how do I quickly debug the inners of my agent's logic to figure out what's going on? Five, once I've got two different versions of my agent, how do I easily compare them to understand if my fix works? Did quality go up overall, but some questions got worse? Which ones got better? Let's walk through how Mosaic AI and agent evaluation help you solve these challenges. Let me switch over to my notebook. First, how do I generate high-quality evaluation data to actually run the evaluation? How do I do this without subject matter experts? I'll use agent evaluation's synthetic data capabilities to take my product documentation and turn it into a synthetic evaluation set. So I've loaded the documents. I'm going to go ahead and import agent evaluation synthetic data API. I've pre-written some guidelines to help guide the synthetic data process. These are optional, and you can see they're actually relatively high level. How do I troubleshoot some issue? Did we change feature recently? Then I'll call the API. Let me kick this off in the background while I explain it. I'll pass in those documents I loaded, the guidelines, and I'll tell us how many questions per document to generate. You can see the process is kicked off and it'll start generating synthetic data. Now that the data pipeline is finished, let's look under the hood to see what's happened. The synthetic pipeline has been tuned by our Mosaic AI research team to generate high-quality data that's useful for evaluation. So you can see we've generated a set of questions. For example, what should I check if my Blendmaster Elite won't start? Which documents those questions came from? And then importantly, for each question, a set of facts that the agent's generation should include. This is important. These expected facts enable evaluation downstream to be more accurate, as well as it makes it easier for subject matter experts to check the accuracy of this content. So now that we have about 550 rows of synthetic data, let's go ahead and start with the initial quality evaluation of our agent. To prep for this demo, I built a function calling agent that has a retriever tool inside it, accessing this vector database. Let's just bring that in. And then I've also configured the agent. So you can see this agent, it's using GPT-4o, it's got a handful of prompts, and it has that retriever tool that I mentioned. To understand how it works before we evaluate it, let me run it. The agent has been instrumented with ML flow tracing. So we'll be able to see exactly under the hood all of the steps that are happening. Now, this is great later for debugging when you have issues, but also useful to see the logic. So you can see It made a tool calling to the LLM, and then it decided to call a vector search tool. How does the blender work? Now that we understand roughly how the agent's working, let's move on to doing the initial quality evaluation. To do this, I'll use MLflow that's been tightly integrated to agent evaluation. So I'll start a run. This allows me to track each version of the code and config that I'm going to be evaluating. So inside this run, which I'll call initial agent, I'm going to go ahead and I'll log the agent's code and config to MLflow. This allows me to track, if my initial version, which settings I had, what prompts I had, what code I had, in case I need to return to it later. Then I'll call MLflow.evaluate. I'll pass in that logged model. I'll pass in the synthetic data from above, and I'll tell MLflow to use agent evaluation. Let's kick this off. Now that evaluation is complete, let's quickly understand what happened under the hood here. When I called MLflow.evaluate, agent evaluation picked up my model and ran every single row in the evaluation set through that model. It then ran its suite of proprietary LLM judges, which are based on Mosaic AI research technology, to understand where there were or weren't quality issues. So let's go ahead and let's take a look at the evaluation results. Here, you can see our intuitive UIs that help you understand where the quality problems in your agent are. So overall, we can see we got about 460 that were correct, but about close to 100 that had an issue. What agent evaluation does is it helps you identify the root cause of those quality issues. So I can see here that 15% of my overall results, about 80, were failing because the retriever was not returning sufficient information. To understand these, let's dig into an individual result. This UI helps you inspect each single record to understand and develop intuition about why your agent might not be returning high quality responses. First, we tell you the overall assessment. Here, we've identified that it's failing, and the root cause is because the retriever is not returning sufficient information. You can see our explanation here. The ground truth states that the order must be over 100 to use this code. However, the retrieved context did not mention this information. So clearly, there's something going on with my vector database. It's not returning the right information. Now, retrieval quality is not the only thing that our judges look at. Overall, they look at the correctness of the answer by comparing to the ground truth. They check if my model was hallucinated or grounding in the retrieved context, the retrieval quality, as well as the safety. I can scroll down here and I can look at the input, what the model produced, as well as which documents were retrieved. Now, if this isn't enough information to debug the problem, I can also look at the detailed MLflow trace for each record. Here, I can see that the vector search was actually called twice. Now, what I've determined here is I think that my retriever wasn't setting filters properly and had too low of a K. So let's return back to my notebook. Let's go ahead and make a fix to try a fix to see if my hypothesis is right. So first, I've tuned my prompt a little bit to encourage the agent to not use filters, as well as I'm adjusting the number of results, or the K, that are coming back. Let's run this cell to apply the configuration, and then I'll come down here and I'll reevaluate the change. This is the same code that I showed you above, but I'm putting it in to a different run called changed prompt, so I can track this. Let's go ahead and let evaluation run. Okay, now that evaluation is finished, let's go ahead and compare it to the previous evaluation run. Okay, so here I can see agent evaluations compare to runs view. This view helps me understand if a fix that I made actually had an impact. So here, first of all, I can see that I have gotten 41 questions more correct. So compared to my initial run, I had 464. Now I have 505. I can see that the root cause of context efficiency has gone down. And I can see that 35 questions improved in context efficiency. So my change has made an impact. However, I can also see that some questions are less grounded. Now, I can review here question by question. I can see which ones went from passing to failing, which ones are still failing. And then I can also look at which ones got better. So let's take a quick look. Here, I see the same view as before, except that I can compare my two runs. So I can see the same question was asked. I can compare the model outputs. And I can see in this one, I had increased my K, so I am getting more documents back. I can look result by result to understand what I need to change to further improve quality.